So what I wanted to do is take you really quickly through one tool in this space, which is a tool called InSpec. But this is a really simple demo around a bit of a TDD workflow. So there's a number of tools under the hood here. Suffice to say I have a box running. I'm assuming that all of this still works. Hopefully my connectivity's up. Yep. Doop-de-doo. Yeah, here we go. So here's a box I started an hour ago in the middle of the previous presentation. And I have this test here, which I have written, which basically says what I expect is the AWS CLI to be installed. So if I verify this box, I hope in good TDD fashion it will fail. Start with red, right?
So this script at the top is an InSpec language.
Correct. And I have got one more thing, too many things uncommented. So this script at the top, correct, yes. So this is basically using the sort of the Ruby spec syntax extended into with an extra set of matches and describers and other things. Yay! So, well, yeah, this basically describes a control which we can put some words around to make humans happy, which we should be doing to describe the behavior that we're actually looking for. This is a bit Mickey Mouse, but it'll do for here. We have a resource. In this case, this is a pip resource, and then we have a set of matches on this. So what you can see is my tests ran, and in fact, I've got two tests. I have a tools test and I have an NTP test. So my pip test has actually failed, but the NTP one hasn't, and it seems like it's doing a few more things. So maybe let's have a look at that. So this is something a little bit more complicated, but you can understand what I'm trying to do here. You don't need to know how it works. You don't need to know how I got it on the box. You don't need to know what it was. In fact, it gets shipped by default by the image I'm using. So if you think about a mutative-based approach, is if I happen to pick up a box where NTP wasn't installed, I would write the installation for it. And then I wouldn't run a test and it would all be cool. But if I happen to pick this box, this image up, which is an Amazon Linux image, and I went in and troubleshoot, and I went, oh, NTP wasn't there, and I went, oh, cool, NTP install. Or sorry, NTP was working, right? And I didn't do it. And I wrote all my other automation around all the other parts. And then I went to go and port to another platform or another distro, or I maybe upgrade to a new version where they've changed the defaults of the operating system, or maybe I applied some patch that uninstalled something or disabled something. My application might fail. But it wouldn't fail because I would know why. Like, you know what the problem with NTP drift problems become on servers, right? You don't see this as an NTP problem. It comes up as so many other issues. But eventually you trace it back and you go, crap, it's because the time's out by 4 seconds. Kerberos login issues, right? All of these things. So what this lets me do is, even if I didn't install the product, which I didn't, I can still assert that's a really key component of my infrastructure. So I describe the behavior that I'm looking for. I'm expecting NTP to be installed. I'm actually expecting it to be running. And I expect that there are processes including those things for some reason. So in a TDD fashion, what I do is I go and I find my code that actually installs pip and CLI for me, which is this. I run converge, and then I run test again and it should go green. So the one thing that I really like about this is, where I'm currently working at the moment, we have an AMI pipeline that's 4 AMIs deep. So we build a golden image up the top, and then it gets layered by something, and then it gets layered by something, and then it gets layered by something and comes out the other end. And usually, functionally, we're going to be totally cool, because the people that are adding their additive functional stuff on make sure that their functional stuff is cool. But we do a lot of security and hardening and log management and performance stuff right down early, right? And I have no visibility that that's still in place by the time it goes through to someone else. They've gone through and enabled root passwords, and they've set a password on the root user for the word password. I've lost control of that now, right? Like I've given the keys to the kingdom. What is that doing? It's one step ahead of me. So what InSpec lets you do is it lets you run a composable set of profiles. So for security specifically, there's this profile here called security. So this was my Well, you can't really see over there very easily. But what this is my example security tests. But what you'll actually find is there are no real controls in here, right? There's nothing of massive depth. I go back in here and I turn them back on because I turned them off. When I run verify this time, what you'll see is that it verifies about 180 other aspects of the code base. And this is because the DevSec guys, who are a group of open source devs, these guys on GitHub, have built a set of standardized profiles for a whole range of security-based compliance approaches. So this is the base operating system one, looking for common kernel parameters and other bits and pieces on the box. They have an SSH baseline that makes sure that your SSH clients are set up in a secure way with removing SHA ciphers from things that I don't even know about. I only know that because I had to re-enable it. But lots of nerdy, edge computer security hardening practices. And they give you a set of profiles that you can run. So you can see now it ran 125, 6 failed. That's probably my fault. But that the kernel net dad transmits should equal 0. I don't know what that means. I don't want to know what that means. Someone else did the work and said this is a sensible default for a secured box, and I can run this. The awesome part is I can now run a stage in my CI after those 4 have run that re-executes the exact same set of tests that I ran here for compliance to give me confidence that nobody's stuffed with it at the end. And if we go one step further, in AWS, you can actually schedule these profiles to run as part of SSM on the hosts in real time and give you a real-time view on actually how packages have drifted, whether any systems are being mutated in flight. And this doesn't require you to test the application. This is just the infrastructure underneath it, that drives exist, that they've got enough space on them, that they're owned by the right people, like lots of really cool stuff. And the awesome bit is it's declarative, which is what we want from our test framework. We want to understand the behavior we're looking for at the end. And it's nicely decoupled from the actual provisioning work. You can provision, you can make the system conform to the tests however you want, which is what is good with a good test framework. You can write it in Chef or Ansible or Puppet. You can go into the box and type the commands. I care not. But as long as you pass my tests, you're good to ship to prod.